So this video we're going to be looking at midpoint and trapezoidal rule, which is better, which has less error, and what actually means error. And so you have our actual value for our integral, our definite integral, and we have the approximation we've been finding using trapezoidal and midpoint rule. And the error is that difference between the two. So if you were to take the approximation, do we have to add something to make this, or do we subtract it? And so if we had to add it, that would be positive error, and if we have to subtract it, it would be a negative error. But basically, our error is just our integral from a to b of f of x dx minus our approximation. That's all we have to do to find the error. So what do we need to know first? What is our actual value for this definite integral? So we can plug it in the calculator, or we can use Desmos. And so if we use our calculator, we get 41.33. So that's 41 1/3. So just so that we have, math is what I was supposed to hit, inner, 124 over 3. So it's basically 41 1/3, but we'll put 41.33. And you can calculate these by hand. It's repeating if you want to as well, but a lot of these are not integrable in this section. So you need to be able to have some sort of approximation for it. So we're going to use the calculator for this. And to make this quicker, we've already done each of these before. I've already picked a basic one. So I don't want to go and do trapezoidal rule and midpoint rule. Trapezoidal, it's going to be a long video. We got 5, 5, 5, 5. I mean, we're talking at least like a 30-minute video. So what we're going to be doing is just using the Desmos graph to write down what the approximate area is, and then subtract it from the actual to find the error. So that's what this video is about, is the error and comparing them. So let's look at our Desmos. So if we were to use trapezoidal rule on this, we would end up with 42. And if we were to use midpoint, we'd end up with 41. So you can see there's our 41.43. So we have 41 and we have 42. One is an overestimate, the other is an underestimate. So this one is an overestimate of 42, and this one is an underestimate of 41. Now, if we subtract them then, for our area, we just take and subtract these two. So that's not our area, sorry, put it in the wrong spot. This would be our trapezoidal rule. So for 4, we would end up with 42. And for midpoint with 4, we end up with 41. So now if we take our actual value and subtract our approximation to it, it's going to tell us our area. So 41.33 minus 42, and then 41.33 minus 41. It's going to give us our error. So let's plug those in the calculator now. So all we have to do is take the calculator value and hit minus 42, and that gives us negative 2/3. So negative 0.6666667. Good enough. And then we're going to do it again. So we're going to scroll up, grab it, and this time minus 41. And we end up with 0.33333. So which is better? Midpoint. Midpoint will always be better than trapezoidal. You can actually see too that one overestimates and the other underestimates. They're always going to be opposite signs when you look at trapezoidal and midpoint. And there's also a factor of 2 here. Look at this. This is half. It's literally half of whatever this one is. So let's look at it again now with more subintervals. We're going to do it with 8. I just copied and pasted. So this reinforces it that it's 8. It was on purpose, see? So now you have to write 8 to know it. So we're going to do it again now with 8 subintervals. So we'll go back to the Desmos graphs and just change it to 8. So we'll do midpoint first. Let's move it up to 8. Right there. So now we have 41.25. So that's now our approximation for midpoint, 41.25. So our M8 here is 41.25. So you can see it got closer because obviously more subintervals we fill it in. So as we increase the number of subintervals, you can see the numbers get really, really close. Look at that. So I'm at 200 subintervals. You can see it's filling it in. So the more subintervals you have, the better your approximation, the worse it is. So you can see even there, it's already got the 41.322. And then if I do some more, wrong one, sorry. Come on, right there, pinpoint. Right. If I do some more, you can see now it's 41.33. And see how we're just getting closer and closer and closer. So let's go back to 8. Okay, perfect. All right, so we have 41.25. Now let's look at trapezoidal. So with 4, we had 42. And so if we move this up to 8, we're now at 41.5. See, so 8's better. And same idea. You can see, remember, if we go really large, you can see now we're at 41.46. You can see it's getting smaller because we're coming in from the top on this one. All right, trapezoidal is overestimating on this one, and the midpoint is underestimating. They're always opposite. So one is basically coming in from the top, the other is coming in from the bottom. So you can see we're now at 20. So let's go back to 8 because we need that number. All right, so 41.5 is what we get. So 41.5 is our estimate with 8 subintervals. So trapezoidal with 8 is 41.5. So now let's see what we get. So if we do 41.33 minus 41.5, our error is going to get smaller. 41.33 minus 41.25, our error will also get smaller. So we get negative 0.166 and 0.083. So just like before, we get negative 0.16667 and 0.08333. So you can see again, one is negative, one is positive. So trapezoidal is overestimating in this situation, and midpoint is underestimating in this situation. You can see that it's half. So midpoint is better than trapezoidal for approximations. All right, and just to prove this, we're going to look at a little picture. So before that though, by the way, just so error, this is what you're finding. So if they say find the actual error, we're going to be doing a video later that says error bound. And so we want to find out what the bounding is for the error. That's a completely different situation. This is find the actual error. So all you do is take the actual value, subtract what your approximate was, and it tells you what the error is. If it's negative, that means we overestimated. And if it's positive, that means we underestimated. So the error that we have here, see, has to be negative in order to get it back to where we are. We'd have to subtract it from here. So we had to take 41.5, subtract something to get it back to 41.3. We'd have to take 41.25 and add something to get it back to 41.33. So this is a positive error, negative error. All right, so now let's look at why this is true. All right, so you can show this mathematically, but we're going to look at it visually. So, because it's not something I want to do mathematically. So here we go. Midpoint. So if we take our midpoint right here and cut it in the middle, and then we put a tangent right there. So you can see there's our tangent line. I'm going to draw it in red right here. This is our tangent. And we're just picking the tangent at that point in order to cut the graph. And so I've actually kind of moved it up a bit to kind of get this idea. But you can see how I cut the graph. So now we can take this little piece of triangle and move it over here. So if we take this and we're taking this rectangle, cutting off that triangle and sticking it here, and we end up with this triangle. So you can see this area in pink here is the exact same area as that area in pink. And this is all done on Desmo, so this is actually exact. That area is that area. Okay, now if you look at the trapezoid from that point, so if we were to find the trapezoidal area for that little piece, remember we're just taking one tiny section. So that's what you want to look at here, is that we've taken one of these little tiny pieces and put it here. Okay? So we're just looking at one because they're all going to be the same on this curve because it's all concave up for this curve. Right? Okay. So now if you look at it, that line is drawn across. This line goes from here to here now for trapezoidal. So if we compare these little white areas here, that's the underestimate. That is our error. So this is our error for the pink. And this part right here is our error for the green, for the trapezoidal, because the area under the curve is literally right here. This is the actual area underneath the curve. So you can see we have an underestimate error, right? That's our overestimate error. So when we're doing these parts, all we're doing is adding up all of these little pieces for the midpoint to get this error. And for the trapezoidal, we're adding up all those little extra pieces, those little pieces that are above, we're adding them all up to find the error as well. And they're over, so they're negative. These are under, so they're positive. All right, but if you look at this, if I take that one and place it here, and I take those little pieces and put it here, you can see that the trapezoidal is bigger than the midpoint. So there we go. Midpoint's better. Now, obviously, midpoint is harder to calculate because you got to find the midpoint. So if you're doing like 10% intervals and you got to cut those into half, it's decimal form. So it is calculation heavy. This one's a lot simpler to plug in. So they're both estimates. Pick the one you like better unless you have to choose. I mean, unless you're told to use one. But yeah, this is how you find error. So it's just take the actual value, subtract your approximation, and it tells you the error. Negative means you overestimated it. Positive means you underestimated.